We're coming up to the new model, to the next model devoted to the blockchain technology and its usage in the banking, preferably. Okay, let's start. First of all, welcome to our new model on blockchain technology and cryptocurrencies. And I'm excited to guide you through one of the most revolutionary technologies of our time. And in this module, we'll be exploring several key aspects that I believe are crucial for understanding the future of digital finance. And first, I will introduce you to the fundamental concepts of blockchain technology and a fascinating system that's much more than just a backbone of Bitcoin. So we will go deeper into the decentralized nature of blockchain, which in my experience is often the most challenging concept for students to grasp initially. And I'll show you then how this decentralization creates a level of security that was previously impossible in digital transactions. And I will also explain the cryptographic principles that make blockchain so secure. And don't worry if you are not a cryptography expert. So I'll break it down into understandable concepts. And we will explore then how the security features work in practice. And what I find particularly exciting here is what I want to share with you is how blockchain technology extends far beyond cryptocurrencies. And we will examine various real-world applications that are already transforming industries. And finally, we'll look at different types of cryptocurrencies and their role in the digital economy. And I believe this knowledge will be invaluable for your future careers and in finance, for example, and even in technology. So let's begin this journey together into the world of blockchain and cryptocurrencies and their usage in banking. First of all, before we go deeper into the blockchain, let me explain why we need an alternative to the traditional banking system. This is something I've studied extensively throughout my career in financial technology. But in our current centralized banking system, everything revolves around a single point of control. And while this might seem efficient at first glance, I want you to think about the inherent vulnerabilities this creates. It's like putting all your eggs in one basket. For example, and I've seen firsthand how this can lead to significant problems. Let me give you a concrete example. For example, when a central bank system fails, it affects every single transaction account holder. And for example, I remember when several major banks experienced system outages, like millions of customers couldn't access their money or couldn't make payments. And this is direct result of relying on a single point of control. And moreover, the centralized nature makes these systems particularly attractive targets for fraud. For example, hackers only need to breach one central point to potentially compromise millions of accounts. And for example, I've analyzed numerous cases where this exact vulnerability led to massive data breaches and financial losses, for example. And this fragility in our banking system isn't just a theoretical concern, it's a real issue that affects consumers' trust and their financial stability. And this is precisely why I believe understanding alternative systems is crucial for everyone studying modern finance. And this vulnerability in centralized banking is what led to the development of blockchain technology, and which we are going to explore next. Just a second. Well, now let me explain one of the most fundamental shifts in financial technology that I've witnessed in my career. That is the move from centralized to decentralized systems. For example, when I compare traditional banking networks to blockchain networks, the difference is striking. Uh, for example, imagine, if you will, a traditional bank as a single castle within high walls. For example, impressive but vulnerable for a focused attack. And now, contrast this with the blockchain's decentralized network, which I like to think of thousands of smaller fortresses, each protecting a piece of the whole system. So, in my experience teaching this concept, for example, I find it helpful to use this visual representation, like you can see here in the diagram on the right of the slide. For example, here you can see how a centralized network channels everything through one hub. So that's our traditional banking system. But look at the blockchain network. It's distributed across multiple points, making it inherently more resilient. And what fascinates me about this transformation is how it completely reimagines security. For example, when a transaction occurs in this decentralized system, it's verified by multiple nodes simultaneously. And I've seen the system withstand numerous attacks, and because even if some nodes are compromised, the network as a whole remains secure. And this shift isn't just about improving security, it's about creating a more demographic and resilient financial system. And for example, in my view, this is one of the most significant innovations in financial technology since the invention of electronic banking, even. The next slide. Now let me share with you what I consider to be the real breakthrough in blockchain technology, which is the distributed ledger system that powers cryptocurrencies like Bitcoin, for example. And in my research and practical experience with blockchain systems, I found that the true genius lies in how the ledger maintains its integrity. For example, you can think about the following way. Every single transaction is recorded in multiple places simultaneously. And as I often tell my students, for example, it's like having thousands of accounts all keeping the same exact records, making fraud practically impossible. What I found particularly fascinating in the consensus mechanism uh, is this consensus itself. So let me explain how it works in practice. When, for example, someone tries to make a fraudulent transaction, the system doesn't just rely on one authority to catch it. Instead, the network automatically compares all copies of the ledger. And if something doesn't match up, for example, it's immediately rejected. And I really believe this technology represents a fundamental shift in how we think about money. For example, if you consider traditional cash, it's physical, it can be lost, stolen, or counterfeited, for example. But with a digital ledger system, we have something that's simultaneously more secure and more efficient. And the implications of this are enormous. Uh, for example, from my work with financial institutions, I can tell you that many are already exploring how to implement this technology. It's not just about cryptocurrencies anymore, it's about creating a new foundation for all financial transactions. And now let me take you back to where it all began, which is the fascinating origin story of blockchain technology. And as someone who studied the evolution of financial technology, I can find this history particularly enlightening. It all started in 1991, and I think it's crucial for you to understand these beginnings. Um, the matter is that two researchers, Stuart Hubbard and Walter Scott Stornetta, were grappling with a fundamental problem. That is how to timestamp digital documents in a way that could be tampered with, for example. And this might sound simple, but it was a groundbreaking challenge at that time. And what I find particularly interesting here is how they collaborated with Bayer the following year to incorporate what we now know as Merkle trees. So named after Ralph Merkle, who patented them in 1979. And let me tell you why this was so significant. Because Merkle trees allowed for efficient and secure verification of large data structures, which is still a fundamental component of blockchain technology even today. And for example, when I speak about that, I always emphasize that these early innovations laid the groundwork for everything that followed. For example, the concept of cryptography and the cryptographically secured chains of blocks was revolutionary. Though at the time, nobody could have predicted how it would transform the financial world. And this background is essential because it shows how the blockchain wasn't created in a vacuum. It was built on decades of cryptographic research and innovation. And therefore, understanding these roots helps us better grasp the technology's potential and limitations. Now, let me tell you about what I consider the most pivotal moment in blockchain history. The mysterious emergence of Satoshi Nakamoto in 2008. And this is where the story gets really interesting. What fascinates me most about this period is how one individual or perhaps a group, we still don't know for sure who they are, managed to solve a problem that had puzzled cryptographers for decades. For example, Nakamoto's breakthrough wasn't just technical, it was conceptual. The matter is that they figured out how to create a distributed blockchain system that didn't need trusted parties for verification. And in many years of studying blockchain technology, I've come to appreciate just how revolutionary this innovation was. For example, you see, the real genius wasn't in creating a new type of database. It was in designing a system that could maintain its integrity without any central authority. And this was something entirely new. And what I find particularly remarkable is how Nakamoto improved upon previous designs. For example, they created a way to add blocks to the chain that was both secure and decentralized. And for example, I often emphasize that this was the key innovation that made Bitcoin possible. And the impact of this development cannot be overstated. Because, for example, in my view, it marked the beginning of a new era in both technology and finance. And it's not just about the technology itself, it's about fundamentally changing how we think about trust and verification of digital systems. Now let me walk you through what I consider the first revolutionary phase of blockchain evolution, which is the birth and early years of Bitcoin. And this period from 2008 to 2013 was absolutely crucial for the technology we use today. And I want to clear up a common misconception I often encounter. That is, many people think Bitcoin and blockchain are the same things, but they are not. And understanding this difference is crucial because Bitcoin was simply the first application of blockchain technology, albeit a groundbreaking one. But when Satoshi Nakamoto released that first white paper in 2008, I remember how it sent ripples through the financial technology community. And what made it so revolutionary was its description of blockchain as an electronic peer-to-peer system. And let me emphasize this point. For the first time, we had a way to transfer value digitally without any intermediaries. And the genius block, that is what we call the first block Nakamoto created, was just the beginning. And from there, other blocks were mined, forming one of the largest chains of blocks in existence. And in my analysis of this period, for example, what's particularly fascinating is how quickly the network grew and how robust it proved to be. And this phase laid the foundation for everything that followed. For example, when I speak about that, I always emphasize that understanding these early days is crucial for grasping how blockchain technology has evolved and where it might go in the future. Now, let me tell you about what I consider one of the most significant evolutionary leaps in blockchain technology, which is the development of Ethereum. And this is where the story gets really exciting. And let me introduce you to Vitalik Buterin, a remarkable young developer who saw beyond Bitcoin's limitations. And it's really fascinating about Buterin's approach to how he recognized the blockchain could be so much more than just a payment system. And from my perspective, this was a crucial insight that changed everything. Uh, well, in 2013, Buterin began developing Ethereum as a new type of public blockchain. And what made it revolutionary, and I want you to really understand this, was its added functionalities. For example, while Bitcoin was essentially a digital currency, Ethereum was designed to be a platform for building decentralized applications. And for example, when Ethereum officially launched in 2015, it marked the beginning of what I call the smart contract era. Let me put this all in perspective. Suddenly, we had a blockchain that could handle an enormous number of transactions per day and support both decentralized applications and smart contracts. And for example, in my experience, I found that Ethereum's emergence represents a crucial turning point, for example, because it demonstrated that blockchain technology could be used for virtually any type of digital interaction, not just financial transactions. And this is why I consider it the second major phase in blockchain evolution. And now let me share with you what I see as the most exciting phase of blockchain evolution, which is the explosion of practical applications that began around 2018. And this phase is particularly fascinating because it shows how far we've come from the early days of Bitcoin. And in my analysis of blockchain development, China's role is particularly interesting here because, for example, despite the cryptocurrency ban, they remained at the forefront of blockchain innovation. For example, if you take NEO, for example, often called the Ethereum of China, I've been following its development closely. For example, what makes me uh, uh, and what makes it remarkable for me is its position as the first open source decentralized blockchain platform in China. For example, one development that I find particularly exciting is the interaction of blockchain with the Internet of Things. So let me tell you about IOTA, IOTA. It's a perfect example of how blockchain technology is evolving to meet specific needs. For example, what makes IOTA special, in my view, is its unique approach. No transaction fees and distinctive verification process designed specifically for IoT ecosystems. And for example, from my perspective, as someone who's been studying the field for years, these developments represent more than just technical innovations. So they show us how blockchain technology is maturing and finding real-world applications across different sectors. And now let me break down the fundamental concept of blockchain in a way that I think makes it easy to understand. And in my experience teaching the subject, for example, I found that starting with the basics is crucial. For example, when I explain blockchain to my students, I start by emphasizing three key characteristics. First one is digital, then it's distributed, and then it's decentralized. And let me explain what this means in practical terms. You can think of blockchain as a special kind of digital ledger that exists simultaneously on computers all around the world. And what makes it special is how it handles information security. For example, looking at the structure itself, pointing to the slide, what fascinates me is how elegantly simple yet powerful it is. And the name, for example, blockchain is quite literal. So it's exactly what it sounds like. A linear chain of blocks, each containing transaction data organized chronologically. And in my years of studying blockchain technology, I found that people often overcomplicate, but at its core, it's simple, and it's simply a way of recording information that makes it extremely difficult, if not impossible, to change or hack. And each block contains coded information about transactions, and these blocks are linked together in a specific order. And what I wanted to make away from this is that blockchain isn't just a technology. It's a new way of thinking about how we store and verify information, and genius lies in simplicity and effectiveness. Well, now let me explain blockchain in the simplest way possible. You can imagine, for example, a chain of digital blocks, but not in the traditional sense of those words. For example, when we talk about blockchain, we are actually taking that it's about something quite specific. But what you see on the screen is a visual representation of how blockchain works over time. And for example, you can notice how each blue block is connected to the next one, forming a continuous chain. And this is fundamental to understand blockchain technology. And for example, when I say block, I'm referring to digital information that's stored in a public database, which we can call the chain. And for example, you can think of each block as a container holding important transactional data. And this is really interesting about all of that, these blocks aren't stored in just one place. They're dispersed across multiple computers. So if I wanted to tamper with the information in one block, I would need to change it across all computers simultaneously, which is practically impossible. And also the beauty of the system is its simplicity combined with incredible security. For example, each block which is shown orange, for example, in our diagram on the slide, can only be added to the chain after it's been verified by the network. And this creates an unbreakable sequence of information. And now let me give you a practical example. For example, you can imagine, for example, written a shared diary where each entry is logged and linked to all previous entries. And for example, once you write something, it can be changed without anyone knowing about it. So that's essentially how blockchain works. And now let me show you the actual autonomy of the block in the blockchain. So, and this diagram on the right of the slide actually illustrates exactly what we'll find inside each block, and I think you'll find it fascinating. So looking at the left side of our diagram, you can see a sequence of blocks, for example, 98, 99, 100, 101, and so on. And each block is verified as indicated by those check marks. And this is crucial for maintaining the chain's integrity. And for example, let's zoom on the structure of a single block shown on the right. And you can see here that every block has three main components: a header, a Merkle tree hash, and a transaction ID list. And the header is particularly interesting because it contains what I call the vital statistics of the block, which is version information, a nonce, which is a special number used in mining, a reference to the previous block, and a timestamp. And so you can think of it as the block's ID card, for example. And below that, we have the Merkle section, which is essentially a clever way of summarizing all the transactions in the block. And it was named after Ralph Merkle, who patented this tree structure back in 1979. And it was brilliant because it allows us to verify transactions efficiently. And at the bottom, we have the transactions ID list, which really contains all the individual transaction hashes included in the block's Merkle tree. And for example, when the blockchain ledger size increases, it's because we are adding more of these blocks filled with transaction data. And now, let me walk you through the fascinating journey of how a blockchain transaction actually works. And for example, this diagram shows us the complete life cycle of a transaction from start to finish. So it all begins with the step one, as you can see, where someone initiates a transaction request from their computer. And this could be anything from sending cryptocurrency to executing a smart contract. And in step two, the system creates what we call a block to represent this transaction. So you can think of it as a digital package containing all the transaction data, all the transaction details, amount, sender, receiver, and timestamp. And now here's where it gets interesting. So in step three, this block isn't just stored in one place. Instead, it's broadcast to every node in the network. And for example, when I say node, I exactly mean every computer that's part of this blockchain network. And step four is crucial for security because all of these nodes validate the transaction independently. For example, they check if you have sufficient funds, if your digital signature is valid, and if everything follows the network's rules. And if the validation is successful, then the nodes receive a reward in step five. And this is what we call the proof of work reward. It's like getting paid for being an honest accountant in the system. And finally, in step 5 and 6, the validated block is permanently added to the blockchain, and the transaction is marked as complete. So once it's there, it can never be altered or deleted. For example, that's what makes blockchain so secure and reliable. Next slide. And now let me explain this elegant diagram that shows how blockchain and blocks in blockchain are connected. So it's like a digital chain where each link is secured cryptographically to the next one. So you can look at how each block has two main parts, a header section at the top and a transaction section at the bottom. And this structure is consistent across all blocks in the chain. So what is fascinating is that the header of each block contains something called a hash of the previous block's header. So you can think of this hash as a unique digital fingerprint, for example. For instance, block 2's header contains block 1's fingerprint, and block 3 contains block 2's fingerprint. And each header also contains what we call a Merkle root. This is a clever mathematical way to summarize all the transactions in that block into a single value. It's like having a tamper evidence seal for all the transactions. And the blue arrows showing the connections between blocks are crucial, because if anyone tries to alter a transaction on block 1, for example, it would change block 1's hash, which would then invalidate block 2, and so on through the chain. And this is what makes blockchain practically impossible to tamper with. So we can think of it like a stack of sealed envelopes, for example, where each envelope contains a copy of the seal from the previous envelope. And if you try, for example, to open and reseal any envelope, all the subsequent seals would no longer match. Next slide. Now, let me show you a more detailed architectural view on how blockchain works. And this diagram here on the right beautifully illustrates both the connection of blocks and how transactions are collected within each block. So at the top, you can see what we call the connection of blocks. And here, each block contains a header with 3 key elements. So the hash value of the previous block's header, root of hash tree, and a list of transactions. So you can notice how block 2's second block header contains block 1's hash value, and block 3 contains block 2's second hash value. And this creates our unbreakable chain. And the bottom part of the diagram shows something fascinating, because the collection of transactions, so you can look at how individual transactions labeled, for example, TX21, TX22, and so on, are organized into what we call a Merkle tree or hash tree. And those H symbols in blue circles, for example, they represent hash functions. So you can think of them as one-way mathematical function that take transaction data and convert it into a fixed size string of characters. It's like creating a unique fingerprint for each piece of data. So what's brilliant about this structure is how it builds up from individual transactions at the bottom, through pairs of hash values, all the way to a single root hash value. And this root hash then goes into the block header and effectively summarizing all transactions in the block. And if anyone tried to tamper with even a single transaction, it would change all the hash values above it. Ultimately, therefore, changing the root hash and breaking the chain. And this is what makes blockchain Fort Knox of data security, as I like to say. Now, let me explain three fundamental concepts that make blockchain transactions so secure and trustworthy. And these elements work together to create what I consider one of the most robust transaction systems ever developed. First, let's talk about decentralized transactions. So what makes this special is that we don't need a bank or any third party to mediate our transactions. Instead, member nodes in the network follow what we call a consensus protocol. So you can think of it as a set of rules that everyone agrees to follow to validate transactions. And the second fascinating aspect is what we call irreversible transactions. So what I mean, once a transaction is authenticated by the network and added to the blockchain, it's there forever. So it's like written and permanent ink, so you can't erase or alter it. So this is crucial for maintaining the integrity of the entire system. And the third pillar is hash functions, which honestly I find particularly elegant because every transaction on the blockchain relies heavily on these mathematical functions that create unique digital fingerprints. And these hash values are essential for linking blockchains, blocks together and ensuring the data hasn't been tampered with. So, and you can consider this in the following way. In traditional banking, you trust the bank to keep accurate records. But in blockchain, you are trusting mathematics and cryptography instead. So I personally find the shift from institutional trust to mathematical trust revolutionary. And what's remarkable about this system is that it's self-validating because there is no need for external verification because the integrity is built into the very structure of the blockchain through these three elements working in harmony. Now, let me expand on the different types of nodes by walking you through this hierarchical diagram. It's a fantastic visualization of how nodes are organized in a blockchain network. So, starting from the left, we have two main categories: full nodes and lightweight nodes, which I mentioned earlier. But let's dive deeper into these branches develop. Under full nodes, we have two specialized types, like prompt nodes and archival nodes. So prompt nodes save space by only keeping recent transaction history, while archival nodes maintain this complete blockchain history. So they're like our digital historians. And what I find particularly interesting here is how the archival nodes branch out into four distinct types, like master nodes, mining nodes, staking nodes, and authority nodes. And each has a specific role in maintaining the network's integrity. For example, mining nodes, are the workhorses of the overall proof of work systems like Bitcoin. So because they compete to solve complex mathematical puzzles to validate transactions. And for example, staking nodes, on the other hand, are used in proof of stake systems where they validate transactions based on the number of tokens they hold. And this diverse ecosystem of nodes ensures that our blockchain network remains both decentralized and secure. And each type of node contributes uniquely to the network's overall health and functionality. And now let's explore one of the most fascinating aspects of blockchain technology, which is the consensus mechanism. And this image on the right of the slide perfectly illustrates how network participants come together to validate transactions. For example, what you are seeing here is a visual representation of how consensus works in a blockchain network. So you can notice the hexagon in the center, so that represents a transaction or block that needs to be verified, and the computers around it are nodes in the network. So I particularly want to draw your attention to the green check marks on some nodes, because these indicate nodes that have verified and agreed on the validity of the transaction. And the gray check marks represent nodes that are still in the process of verification. And this is what makes blockchain so revolutionary. Instead of having a single authority making decisions, they have multiple independent nodes that must reach agreement. So we can think of it like a digital democracy where every node gets a vote. And on the one of the most interesting aspects is that any user can become a full node in the peer-to-peer network, because by doing so, they gain the ability to participate in the consensus process. But however, this also raises some interesting challenges, like which I will discuss in our next slide. So, and overall, in my experience, this distributed consensus mechanism is what makes blockchain nearly impossible to manipulate, because unless majority of nodes collude, which we'll discuss when we talk about 51% attacks, then the network remains secure and trustworthy. Now, let me explain one of the most significant security threats to blockchain networks, which we call a 51% attack. And this diagram illustrates how it works, because and it's something every blockchain professional needs to understand perfectly. Look at the top of the diagram. So this represents the legitimate blockchain where honest miners, for example, shown with the construction helmet icon, are adding and broadcasting blocks openly. And this is how the system is supposed to work. However, notice at the bottom chain with the figure wearing sunglasses. So, and this represents an attacker. What they are doing is creating their own private chain of blocks without broadcasting them to the network. It's like they are reading their own secret ledger, for example. And here, where it gets concerning, because if an entity controls more than 51% of the network's mining power, they could potentially force the network to accept their private chain as a legitimate one, and this would effectively allow them to rewrite transaction history. And what makes this particularly dangerous is that once a group controls more than half of the nodes, they can change consensus rules as they see fit. And this could lead to what we call a monopoly situation, exactly what blockchain was designed to prevent. And this vulnerability is why maintaining a truly decentralized network is crucial. Because in my experience, the best defense against 51% attacks is having a large, diverse network of independent miners and validators. And now let me introduce you to the first and most well-known type of blockchain architecture, which is a public blockchain. It's what most people think of when they hear about blockchain technology. So a public blockchain, as the name suggests, it's completely open and transparent. So you can imagine a giant digital ledger, for example, that anyone in the world can not only see, but also participate in. It's like a public park, so open to everyone. And what makes public blockchains fascinating is that they allow any user on the internet to verify and modify transaction blocks. This level of openness creates an unprecedented degree of transparency in digital transactions. So, going on, let me give you some concrete examples. For example, Bitcoin, which pioneered blockchain technology, is a public blockchain. And Ethereum, which introduced smart contracts, is another prime example. Dash is, for example, yet another well-known public blockchain. And the beauty of the system is its complete decentralization. So there is no central authority controlling access or any permissions. And everyone has equal rights to view, to verify, and to participate in the network. However, this openness comes with trade-offs in terms of transaction speed and energy consumption, which we'll discuss when we compare it to the other types of blockchains. And now let's explore private blockchains, which represent a fascinating evolution in blockchain technology. So they operate quite differently from the public blockchains we just discussed. You can think of a private blockchain as a gated community within a single organization. For example, unlike public blockchains where anyone can participate, private blockchains are much more selective about who gets to do what. What I find particularly interesting about private blockchains is their hybrid nature. Because while the content of blocks can still be viewed by anyone on the internet, maintaining some level of transparency. The ability to manipulate or add to these blocks is strictly controlled. So let me emphasize this point. In a private blockchain, only specific individuals within the organization have the permissions necessary to verify transactions and add new blocks to it. And these make them ideal for businesses that need both security and control. For example, platforms like Multichain and Blockstack, for example, are excellent examples of private blockchain implementations, because these solutions allow organizations to maintain control while still leveraging the benefits of blockchain technology. And for example, in my experience working with organizations, private blockchains often provide the perfect balance between the transparency of blockchain technology and the control requirements of traditional business operations. Next slide. And now let me explain what makes consortium blockchains unique and why they are particularly valuable for organizations. Well, unlike public or private blockchains, consortium blockchains operate under a different model of control and access. And for example, in my experience working with various blockchain implementations, I found that consortium blockchains offer an excellent middle ground, because we can think of them as a hybrid solution. So they are neither completely open like Bitcoin, nor fully closed like private corporate blockchains. And what makes them special is that only a pre-selected group of organizations or individuals can verify and add transaction blocks. So I like to give an example of Ripple, for example, because it's one of the most well-known consortium blockchains, along with R3 and Hyperledger 1. And the ledger of a consortium blockchain can be configured to be either open for everyone to view, for example, or restricted to specific groups only. And this flexibility is particularly valuable for industries where, for example, multiple organizations need to collaborate while maintaining high security standards. And for example, in my consulting work, I've seen many organizations across different sectors who chose consortium blockchain specifically for their enhanced security features. And for example, when my students ask me about real-world applications, I often point to financial institutions that need to share data with partners while maintaining strict control over who can validate transactions, because this balance between collaboration and control is what makes consortium blockchains particularly attractive for enterprise use. Well, next slide. And Now I want to help you understand the fundamental concept of blockchain, of Bitcoin blockchain, because it's crucial for grasping how modern cryptocurrency system work. So let me start by saying that before we dive into the technical aspects of how Bitcoin and blockchain interact, so it's essential to understand the basic precepts of Bitcoin itself. So I often find that students get confused between Bitcoin and blockchain, but they are not exactly the same thing. So we can think of Bitcoin as a specific application of blockchain technology. For example, when I explain this to my industry colleagues, I describe Bitcoin as a form of electronic cash, which is, for example, a cryptocurrency that functions similarly to traditional currency units, but with some, unique characteristics. And for example, in my years of studying digital currencies, I've observed that Bitcoin represents one of the most successful implementations of blockchain technology. And I think what makes it particularly interesting is how it combines several technological innovations to create a completely new form of money. And here, I want to emphasize that while Bitcoin might seem complex at first, its underlying principles are actually quite elegant. Because as we progress through this course, you'll see how Bitcoin uses blockchain technology to solve problems that has stumped digital currency developers for decades. Because this relationship between Bitcoin and blockchain is one of the most fascinating aspects of modern financial technology. And I think that understanding it is crucial for everyone interested in the future of finance. And now let me walk you through how the Bitcoin blockchain actually works in practice. I find this diagram particularly helpful in explaining the system's architecture that you can see on the slide. So looking at this illustration, you can see the key components of the Bitcoin ecosystem. So let me break it down for you. At the top, we have a block miner who plays a crucial role in validating transactions. And on the left and the right, we have senders and receivers. These are the users conducting transactions. What I find fascinating about this system is its peer-to-peer nature, because you can notice how there is no central authority controlling the process. And instead, as shown in the center of the diagram, we have a distributed ledger. That's our blockchain, which is connecting all participants. For example, in my experience teaching this concept, students often ask about the role of traditional financial institutions. So as you can see in the lower part of the diagram, while banks and exchanges are parts of the ecosystem, they are not controlling the transaction process. Instead, they're interfacing with the blockchain network just like other participants. And for example, the money transfer services shown on the bottom represent the practical application layer where Bitcoin meets traditional finance. And this is where, in my view, the real innovation of blockchain technology becomes apparent, because it creates a trustless system where transactions can be verified and recorded without requiring a central authority. So let me emphasize that this is a simplified model, but nevertheless it captures the essential elements of how Bitcoin's blockchain operates in practice. And I think that the beauty of the system is its ability to maintain consensus across a distributed network while ensuring security and transparency. Next slide. Now, let me draw your attention to a crucial distinction that I believe is often overlooked in blockchain discussions. For example, when we compare Bitcoin's blockchain to business-oriented blockchains, there are three fundamental differences that I want to highlight. From my experience working with both cryptocurrency and enterprise blockchain solutions, I've observed that these distinctions significantly impact how each type of blockchain is implemented and used. And many of my colleagues, for example, in the industry, initially struggled to understand why we couldn't simply apply Bitcoin's blockchain model directly to business applications. And what's particularly interesting here is what I will explain in more detail in the following slides, is how these differences shape the way transactions are processed and how identity is managed and how consensus is achieved as well. And these three characteristics form, I would say, the foundation of why businesses often need a different approach to blockchain implementation than what Bitcoin offers. So I find it fascinating how these differences emerged naturally as a blockchain technology evolved from its cryptocurrency origins to broader business applications. Because in my consulting work, for example, understanding this distinction has been crucial for helping organizations choose the right blockchain architecture for their specific needs. And now let's examine each of these characteristics in detail, starting with the first major difference in the next slide. So I think you'll find it illuminating how each characteristic addresses specific business requirements that differ from Bitcoin's original purpose. And now on the next slide, let me explain one of the key differences between Bitcoin's blockchain and business-oriented blockchains, which is their approach to assets. This is something I find particularly fascinating in my research and practical work with blockchain implementations, because let me explain this. Actually, when most people think about blockchain, they immediately think of cryptocurrency. And however, I would like to emphasize that blockchain technology has evolved far beyond just digital currencies. Because, for example, in my experience working with various industries, I've seen blockchain being applied to an incredibly diverse range of assets. And what I find more exciting about business blockchains is their versatility. Because, for example, unlike Bitcoin's blockchain, which was specifically designed for cryptocurrency transactions, business blockchains can handle virtually any type of asset you can imagine. So, because, for example, I've seen them used for everything from supply chain management to real estate titles, from intellectual property rights to energy trading even. And what is particularly interesting here, and what I often tell to my students, is that this broader application of blockchain technology actually opens up more possibilities than the original cryptocurrency use case. And for example, when we move beyond just thinking about digital currency, we start to see how blockchain can revolutionize almost any industry that deals with asset tracking and transfer. And for example, in my consulting work, I have observed that these flexibilities in handling different types of assets is often what makes blockchain technology so attractive to business, because it's not just about moving money anymore. It's about creating new ways to track, transfer, and verify ownership of any kind of assets. And now, by this slide, let me explain another crucial distinction between Bitcoin blockchain and business blockchains, which is their approach to identity. This is something that I believe fundamentally shapes how these systems operate in practice. Because, for example, when I teach about Bitcoin's blockchain, I always emphasize that one of its core features is anonymity. That's what makes it so unique. That is, users can conduct transactions without revealing their real identities. However, in my work with businesses, I have found that this approach simply doesn't align with real-world business requirements. So, let me break this down into three key points. First, Bitcoin's blockchain thrives on anonymity. That's a fundamental part of its design. But, and this is crucial, businesses operate in a regulated environment where know your customer or KYC and anti-money laundering or AML compliance are non-negotiable requirements. And here's what I find particularly interesting. Business blockchains actually need to be designed with these compliance requirements in mind from the ground up. And in my experience consulting with financial institutions, I've seen actually how they must maintain a delicate balance between transparency and privacy. And finally, I want to emphasize that this isn't just about following regulations. It's about creating systems that work in the real business world. So, because otherwise, when I discuss this with my industry colleagues, we often note how this identity-centric approach actually enables more sophisticated business applications while maintaining necessary compliance standards. And now let me explain the third major distinction between Bitcoin's blockchain and business blockchains, which is their consensus mechanisms. So this is one of the most significant architectural differences I've encountered in my research and practical work. Well, in business blockchains, we use what I call selective endorsement in order to achieve consensus. So let me explain what this means with a practical example that I often share with my students. So you can think about when you transfer money to a third party, your transaction is verified by your bank and also the recipient's bank and possibly a payment provider. And this is selective endorsement in action. And what I find particularly fascinating about this approach is how it differs from Bitcoin's proof of work system. And for example, in my consulting experience, I've seen how businesses can achieve much higher efficiency by allowing specific and trusted parties to verify transactions rather than requiring network-wide consensus. And here's what makes this so powerful, because businesses can control exactly who verify their transactions. And this not only makes the process more efficient, but also aligns with existing business relationships and regulatory requirements. And for example, I have implemented such systems where specific industry partners act as validators, creating a perfect balance between trust and control. And finally, let me emphasize that this is a fundamental shift from Bitcoin's approach, because while Bitcoin needs proof of work to maintain trust in, for example, an anonymous network, businesses can leverage existing trust relationships to create more efficient consensus mechanisms. Now, let me walk you through the fascinating process of blockchain mining, which is essential for securing and verifying Bitcoin transactions. And this diagram here on the right perfectly illustrates the complete mining cycle. For example, in my years of studying blockchain technology, I found that mining is often misunderstood. So let me break down this process step by step, following the arrows on our diagram. So it starts with what you see on the top left, a transaction being initiated on someone's computer. So we can think of this as someone's wanting to send Bitcoin to another person. What happens next is particularly interesting because the transaction details are broadcast to miners across the global network, and that's represented by the globe icon in our diagram. So I often tell my students to imagine this as a worldwide announcement saying, for example, hey, there's a transaction that needs to be verified. And the miners then compete to complete the verification process shown by the PXX symbol. So what I find fascinating about this part is that miners are essentially solving complex mathematical puzzles. So when a miner succeeds, they not only verify the transaction, but also get rewarded with new Bitcoins. So you can look at the bottom of the diagram. You can see how the verified transaction gets added to the blockchain and creating the permanent unalterable record. And finally, the transaction is marked as complete, represented by the handshake icon. Well, what makes this system particularly brilliant, in my experience, is how it creates a self-sustaining cycle where miners are incentivized to maintain the network security through the reward system. And now let me delve into the different types of mining that exist in the blockchain ecosystem. So this is a topic I'm particularly passionate about because it shows how blockchain technology has evolved to accommodate different levels of participation. So in my experience teaching blockchain technology, I found that many students are surprised to learn that mining isn't just one uniform process. And the complexity of mining operations mean that the regular desktop or PC simply isn't sufficient anymore. And this is something I learned firsthand when I first started researching blockchain technology. And what I find particularly interesting here is how mining has developed into the sophisticated operation requiring specialized hardware and software. And when I consult with the companies interested in mining operations, I always emphasize that importance of having the right setup of their specific mining goals. So now let me share something from my practical experience. That is, each type of mining requires a unique combination of equipment and approach. And it's crucial to understand that what works for one type of mining might not work for another. So, because for example, I've seen many newcomers make the mistake of trying to mine with inadequate resources. And in the next slide, I'll break down the three main categories of mining that have emerged in the blockchain ecosystem. And each has its own advantages and challenges. And I think that understanding these differences is crucial for anyone considering getting involved in mining operation. Well, now let me talk about three main categories of mining that we see on the blockchain ecosystem today. So these images perfectly illustrate the distinct approaches to mining that have evolved over time. First, let's look at the individual mining shown on the left. So I remember when this was the primary way people mined Bitcoin using specialized hardware called ASICs, like the one pictured. And in my early days studying blockchain, I watched this transition from CPU mining to these dedicated devices. However, I should mention that individual mining has become increasingly challenging due to the growing computational requirements. And for example, in the middle, we see pool mining represented by the creative image of miners working together on a Bitcoin. And this is what I consider one of the most innovative developments in mining. And from my experience analyzing mining operations, I've seen how pool mining allows individuals to combine their resources and their rewards, making mining more accessible to average participants. And finally, on the right, we have cloud mining. So those massive data centers filled with mining equipment. And I've had the opportunity to visit several of these facilities, and I can tell you that they are impressive operations because this approach allows people to mine cryptocurrencies without owning or maintaining any hardware themselves. And what I find particularly fascinating about these three categories is how they represent the evolution of mining from a hobby activity to a sophisticated industrial operation. And each model serves different needs and has its own risk-reward profile, which I will be happy to discuss in more detail if you're interested. The next slide And now let me introduce you to Ethereum, which you consider one of the most revolutionary developments in blockchain technology since Bitcoin. This platform was conceptualized by a brilliant young developer named Vitalik Buterin in November 2013. For example, in my years of studying blockchain platforms, I found that Ethereum represents a quantum leap forward in what blockchain technology can do. For example, while Bitcoin was designed primarily as a digital currency, Ethereum was conceived as something much more ambitious. For example, you can think of it as a global computer that can run decentralized applications. And now let me explain something what I find particularly fascinating about Ethereum. That is its native cryptocurrency is called Ether. But unlike Bitcoin, Ether isn't just designed for financial transactions. In my discussions with the developers, I often emphasize how Ether serves as the fuel that powers the entire Ethereum ecosystem. And what makes Ethereum truly special, and what I always emphasize to my students, is that it introduced the concept of programmable blockchain. And for example, through my work with various blockchain projects, I've seen how this capability has opened up entirely new possibilities that weren't feasible with the Bitcoin alone. And this innovation has led to what I believe is one of the most vibrant developer communities in the blockchain space. And the platforms, for example, flexibility and programmability have made it the foundation for countless innovative projects, from decentralized finance to digital art market. And now let me explain the three fundamental characteristics that make Ethereum such a groundbreaking blockchain platform. For example, from my years of working with the various blockchain technologies, I can tell you that Ethereum's architecture is truly unique. First, let me emphasize its open source nature. And for example, in my experience consulting with blockchain projects, I've seen how this openness has been crucial for innovations. Because Ethereum is not just a blockchain, it's a complete distributed computing platform and operating system. And what is the most exciting here about this is its smart contract functionality, because I believe it has revolutionized how we think about blockchain applications, simply. And secondly, let's talk about distributed applications, or DApps, as we call them in the industry. So what I find remarkable about Ethereum's architecture is that these applications run exactly as programmed without any possibility of downtime, or, for example, fraud, or even interference from third parties. So I worked with many companies implementing DApps, and this reliability is absolutely crucial for their operations. And finally, and this is something I'm particularly passionate about, is Ethereum's turning complete programming language. For example, when I teach this concept, I explain that this means developers can write virtually any kind of program to run on the blockchain. It's like giving developers a complete toolkit to build whatever they can imagine. And in my view, these three characteristics together make Ethereum much more than just another blockchain. As to my opinion, it's a platform for the future of decentralized computing. So the next slide. And now let me explain why Ethereum is more than just a cryptocurrency platform. So unlike Bitcoin, which primarily focuses on financial transactions, Ethereum serves a much broader purpose in the blockchain ecosystem. First, I want to emphasize that Ether, which is Ethereum's native cryptocurrency, plays a crucial role in the platform's operation. because when you are using the Ethereum network, Ether is used to compensate the mining nodes for their computational work. And you can think of it as paying for the processing power that keeps the networks running. But what makes Ethereum truly special is its versatility. And I often, for example, tell my students that if Bitcoin is like a specialized tool, Ethereum is more like a complete workshop. So you can, in other words, you can build practically anything on it. So the platform supports a wide range of applications beyond simple fund transfers. And in my experience working with the blockchain technologies, I've seen how Ethereum has revolutionized the way we think about decentralized applications. And because, for example, you can create smart contracts here, build decentralized autonomous organizations, or even launch your own tokens, all on the Ethereum platform. And moreover, I believe this flexibility and broader applicability is what makes Ethereum such a powerful force in the blockchain space. And in fact, many of the innovative blockchain projects we see today are built on Ethereum's infrastructure. Next slide. And now I'd like to introduce you to the fascinating concept in Ethereum called gas. So, I often compare gas to the fuel that powers your car. For example, without it, you are not going anywhere on the Ethereum network. Let me break down how gas works in practice. For example, when miners process transactions or execute smart contracts on Ethereum, they need to be compensated for their computational work. And this is where gas comes in. So it's essentially a fee-paying system that serves multiple purposes. First, gas acts as a spam prevention mechanism. And if every transaction or smart contract execution required a fee, it becomes economically unfeasible for malicious actors to flood the network with meaningless transactions. So, and therefore, I've seen how effective this is in maintaining network health. And what's particularly clever about the gas system is how it allocates resources. Because every operation on Ethereum, whether it's a simple transfer or a complex smart contract execution, it requires a specific amount of gas. And the more complex the operation, the more gas it needs. And here's an important point I want you to remember, because miners are incentivized to include transactions with higher gas prices in their blocks first. It's really a beautiful example of how economic incentives can be used to maintain network efficiency. And when you are developing applications on Ethereum, for example, then I think understanding gas optimization becomes crucial for cost-effective transactions or operations. And now, let me share with you what I find more exciting about Ethereum's potential applications. So I've been following its development since the early days, and the possibilities continue to amaze me, honestly. First and foremost, Ethereum is revolutionizing how we think about decentralization. For example, in my work with the financial institutions, I've seen firsthand how Ethereum can decentralize thousands of processes across different industries. And we can think about traditional banking services, for example, and insurance or even supply chain management. All of these can be transformed through Ethereum's blockchain technology. And what particularly excites me is how Ethereum is changing the landscape of financial services. For example, if we take loans, for example, traditionally, you'd need multiple intermediaries or lots of paperwork and days of or weeks, even weeks of processing time. And with Ethereum-based solutions, these processes can be automated, made more efficient, and significantly more secure. And finally, let me emphasize this point. So if we were to decentralize all centralized services using Ethereum, and virtually every aspect of our daily lives could become more secure and efficient. So I'm talking about everything from voting systems to property records, from identity verification to even supply chain tracking. And the beauty of Ethereum lies in its programmability and flexibility, because it's not just a platform, it's an entire ecosystem that's constantly evolving and improving. And now I want to introduce you to one of the most revolutionary concepts in blockchain technology, which is called smart contracts. Well, the story begins with the brilliant computer scientist named Nick Szabo, who, while pondering about Bitcoin blockchain security, came up with this innovative idea. So let me paint a picture for you. Imagine traditional contracts. So they require intermediaries, trust between parties, and often a complex enforcement mechanisms. And now what Szabo envisioned was different. He thought about creating a software-based protocols that could automatically facilitate, verify, and enforce contract terms. For example, in my years of studying blockchain technology, I've come to appreciate just how groundbreaking this concept was, because you can think about it in the following way. A contract that executes itself without any need for intermediaries or manual oversight. That's exactly what smart contracts do. And honestly, I find it fascinating how Szabo's original concept has evolved into what we see today in blockchain platforms like Ethereum. And for example, these smart contracts are now revolutionizing everything from financial services to even supply chain management. They are essentially computer programs that automatically execute when specific conditions are met. And the beauty of smart contracts lie in their simplicity and reliability, because once deployed on the blockchain, they operate exactly as programmed. So no exceptions, no human intervention is needed. Next slide. And now let me walk you through how smart contracts actually work in practice. And I often actually use this diagram to explain the process, because it perfectly illustrates the four key stages of smart contracts lifecycle. So it all starts with what we call a predefined contract. And this is where all parties involved agree to specific terms and conditions. For example, in my experience, this is crucial, because once these terms are coded into the blockchain, they cannot be altered. And so we can think of it as carving your agreement in stone. So it's permanent and transparent. And the second stage involves events. So I like to think of these as triggers. For example, if we are dealing with a payment contract, an event might be reaching a specific date or receiving a particular amount of cryptocurrency. And these events are what set the smart contract in motion. And next comes the execution phase. And here, what I find mostly fascinating, once the predefined conditions are met, the contract executes automatically. And there's no need for manual intervention, no paperwork, no delays. It's all handled by the blockchain network. And finally, we reach the settlement stage. So all agreed upon transactions or actions are completely quickly and efficiently. And that's particularly impressive is because this entire process happens without any intermediaries, reducing both time and cost. For example, when I teach this concept, I always emphasize that this automation and efficiency is what makes smart contracts truly revolutionary in the business world. The next slide. This slide illustrates what we call the Byzantine generals problem. And it relates to the blockchain technology directly. And I really find it's one of the most fascinating aspects of how smart contracts maintain security. So let me explain why this is so crucial. Look at these two scenarios in the image. On the left, we see a perfectly coordinated attack where all participants are working together. And this represents how a blockchain should function ideally. And on the right, we see what happens when there are traitors in the system. And this represents potential bad actors in a blockchain network. And the brilliant solution to this problem comes in the form of Byzantine fault-tolerant algorithms. For example, in my years of working with blockchain technology, I've seen how these algorithms effectively ensure that smart contracts continue to function correctly, even when some nodes in the network are trying to act maliciously or simply failing. And what makes this even more powerful is the implementation of Turing-complete programming languages, because these languages allow us to create sophisticated smart contracts that can handle complex logic while maintaining security. And I always, for example, tell my students that this combination, like Byzantine fault tolerance and Turing completeness, is what makes smart contracts truly revolutionary. And you can think of it having a system that can not only detect and ignore bad actors, but also execute complex operations with absolute precision and reliability. Now, by this slide, let me walk you through this practical example of how smart contracts work in real estate transactions. So I find this illustration particularly helpful because it shows the real-world application of what I've been discussing. So look at the top of the diagram, and here we have a seller and a buyer of the house. And in traditional real estate, this process would involve multiple intermediaries, plenty of paperwork, and also significant time delays. But within smart contracts, it's remarkably different. So you can notice the central exchange mechanism, for example. What I find fascinating here is how the smart contracts automatically handles the matching of buyer and seller, and also manages the asset distribution. And here the contract acts as an automated escrow service, if you will. So, and at the bottom, you can see two crucial elements. So first, the digitized land deed and digitized currency. And for example, in my experience, this is where blockchain truly shines, because the land deed is tokenized, meaning it's converted into a digital asset, while the payment is made in cryptocurrency, typically Bitcoin or Ethereum. And the smart contract ensures that both the deed transfer and payment happen simultaneously. And what's particularly powerful about the system is that it's automated and undisputed, because the clearing and settlement process happens without human intervention. And once it's recorded on the blockchain, the ownership is immutable and transparent. And this is why I believe smart contracts are revolutionizing not just real estate, but any industry that relies on contracts and trust. Next slide. Now let me share with you the 6 key benefits that make smart contracts truly revolutionary in today's digital economy. So I've seen these advantages transform business firsthand. Starting with anonymity. This is a game changer, actually, because unlike traditional contracts, smart contracts operate without intermediaries. For example, in my experience, this elimination of middlemen not only speeds up processes, but also reduces the potential for manipulation or human error, for example. And the transparency aspect is equally crucial as well, because I always tell to my students that this is like having a glass house for your agreements, because every party can see exactly what they are getting into. And all terms and conditions are fully visible to relevant parties, which also dramatically reduces disputes. And looking at backup and accuracy, for example, these features particularly excite me because every transaction details is recorded multiple times on the blockchain, making it virtually impossible to lose information. And because it's automated, we eliminate these pesky human errors that block manual form filling, for example. And then the trust element is fascinating because your documents are encrypted in a shared ledger. So you can think of it as having your agreement stored in the world's most secure digital vault. And finally, let's talk about savings. So in my consulting work, I've seen companies reduce costs significantly by eliminating intermediaries, for example, and this benefit alone has made many organizations switch to smart contracts. And for example, these benefits combine to create what I believe is the future of contract management and execution. The next slide. Now let me highlight 2 fundamental aspects that make smart contracts a game changer in modern business transactions. So I've seen these benefits transform operations across various industries, actually. First, let's talk about efficiency and accuracy. And what I find most remarkable about smart contracts is their automated execution, because you see once the predefined conditions are met, the contract executes immediately. No delays, no paperwork, no mutual processing, and manual processing as well. And in my practice, I've seen this reduce transaction times from weeks to mere minutes. It's like having a tireless, perfect employee who never makes mistakes and works 24/7. And the second key aspect is trustworthiness and transparency as well. And this is where blockchain technology really shines, because every single transaction is encrypted and shared across the network. And here I often tell to my students to think of it like having thousands of notaries and all validating your document simultaneously. And what makes this particularly powerful is that once a transaction is recorded, it's impossible to alter it without anyone knowing. And from my experience implementing the systems, I can tell you that this combination of automation and transparency has revolutionized how businesses handle contracts. So it's not just about speed, it's about creating a level of trust that was previously impossible to achieve without traditional contracts. Next slide. And now let me explain 2 critical technical features that make smart contracts so secure and reliable. And in my years working with blockchain technology, these aspects have consistently proven to be the backbone of successful implementations. First, let's talk about encryption. So I wanted to imagine your most sensitive business document, for example. And now in the smart contract, this document isn't just encrypted once. It's encrypted using sophisticated cryptographic algorithms and distributed across the entire blockchain networks. And from my experience, this level of security is virtually impenetrable. It's like having a document locked in thousands of high security vaults simultaneously. And the second crucial feature is the blockchain technology itself, because, I often compare this to a chain of digital DNA. For example, where each transaction, each piece of information is not just recorded, but it's intrinsically linked to every other transaction before and after it. This interconnected nature creates what we call an immutable record. So meaning it's practically impossible to tamper with. And when I work with business implementing smart contracts, for example, I always emphasize that these two features work together because the encryption protects the content, while the blockchain structure ensures the integrity of the entire system. And it's this combination that makes smart contracts not just secure, but truly revolutionary for business operations as well. Next slide. And now I want to discuss some critical challenges we face when implementing smart contracts on blockchain. So let me highlight three main issues that every developer and every business needs to be aware of. First, let's talk about modifications. One and the most significant challenges is that altering a smart contract process is extremely time-consuming, and in some cases even is practically impossible. This is due to the immutable nature of blockchain technology. For example, once deployed, you can't simply edit the code like you would with traditional software. And another challenge that might surprise you is the involvement of third parties. Because, for example, while smart contracts aim to minimize intermediaries, we can't completely eliminate them in practice. And there are situations where contract terms aren't met as agreed, and we need external verification and arbitration. And for example, I've seen that happen in several real-world implementations. And finally, there is an issue of vague contract terms. For example, traditional contracts often contain ambiguous language that humans can interpret based on context and common sense. However, smart contracts operate on strict logic, and it can't handle such ambiguity. They need explicit, precise terms to function correctly. And this also creates a significant challenge when translating traditional legal agreements into smart contracts code. And for example, in my experience working with various blockchain projects, these challenges often catch developers and businesses off guard. That's why it's crucial to understand and plan for them from the beginning of any smart contract implementation. And the next slide. Now, that we have covered the challenges, let me share my perspective on where smart contracts are headed. So I'm particularly excited about their development potential and future applications, indeed. So looking at the current trends, I can tell you that smart contracts are poised to revolutionize complex commercial transactions. Of course, and we've seen innovative applications across various industries, and I believe this is just the beginning. And from my experience working with the blockchain technology, I can say that we are only scratching the surface of what's possible. Because, for example, one area that particularly interests me is how smart contracts are transforming incentive and reward structures in contracts. So you can think about traditional business agreements, like they're often static and require manual enforcement. But with smart contracts, we can create dynamic, self-executing reward systems that automatically adjust based on performance metrics, for example. What's truly revolutionary is how smart contracts are facilitating the transition of traditional contracts into digital platforms. Because, for example, I've worked with several companies that have successfully digitized their contract processes, and the efficiency gains are remarkable. And the ability to automate contract execution while maintaining security and transparency here is, I think, that is a game changer. And here's what excites me the most. There are still so many unexplored possibilities, actually, because as blockchain technology continues to evolve, we'll see smart contracts being applied in ways we haven't even imagined yet. So I believe we're at the cusp of the major transformation in how businesses handle agreements and transactions. And now let me walk you through the 4 key benefits of blockchain technology that make it such a transformative innovation. So I really have seen these advantages firsthand in numerous implementations. First, let's talk about time savings. It's remarkable how blockchain has revolutionized transaction speeds. For example, in my experience, what used to take days in traditional systems, for example, now happens almost instantaneously. And this is particularly crucial in today's fast-paced financial world, I think. And the second benefit, and this is something that often surprises my students, is cost reduction. Because by eliminating intermediaries and overhead costs as well, blockchain significantly reduces operational expenses. And I've really worked with companies that have seen dramatic cost savings after implementing blockchain solutions. And now, security is a major concern in our digital age because this is where blockchain really shines. The third benefit so far is risk reduction, because the technology's inherent structure make it extremely difficult to tamper with or commit fraud. And I can tell you more that the cryptographic principles underlying blockchain provide unprecedented protection against cyber crimes, for example. And finally, and this is perhaps the most interesting benefits, so blockchain increases trust through shared process and record keeping. Now, for example, in my years of working with various organizations, I have really observed how transparent, immutable records create a level of trust that was previously impossible to achieve, for example, with traditional systems. And these benefits combine to create a compelling case for blockchain adoption across various industries. And the next slide is
Because sorry for
yes.
interrupting. About the previous slide about the cost reduction. Um, am I right that like introducing the technology, the company spends, I think, a lot of money firstly, like any other project, to put everything in place. And I think that introducing the blockchains is actually requires to change all business processes of the firm, of the company. And then, for example, in some time, in several years, the costs are lower because of the, I don't know, less workforce and I don't know, less technical support and so on. right? Or there is another way why it removes cost?
Yeah, you're quite right. Very good question. Yeah, there are several notes that I would like to stand on. Actually, first of all, um, you should talk about the blockchain implementation specifically, not in general, actually, when we talk about the financial side of the blockchain implementation. So if we implement blockchain generally just to have it, for example, in a company, that not supports that statement that it reduces costs, for example, because it may not actually, because we may invest, for example, much money into the implementation of the blockchain and, for example, investing much money into changing the business processes, as you said before, that is right without any return on investment, for example, specific return on investment. Uh, uh, this is on the one hand. But on the other hand, for example, when we perfectly understand what kind of problem we solve by implementing the blockchain, and we implement this specific, not scaled up blockchain, not in general, but a very specific blockchain for the specific, in order to solve the specific problem. So, as to my experience, this might be a very beneficial project in terms of the return on investments, for example, and reduction of costs. Because, first of all, we may select the specific predefined blockchain for this purpose. For example, we do not need to implement our own bicycle for this purpose. So there are plenty of the open source blockchains or private blockchains or consortium blockchains that are not very expensive, that might not be very expensive in terms of implementation, for example. So they are predefined, they are ready for implementation. First of all, and second, we can solve a specific problem and we can specifically measure the return on investment on the financial side of this project. And if it's not a beneficial one, for example, in terms of the finances, so we may refuse it, for example, we may deny it. And moreover, it's highly recommended, it's strongly recommended to start implementing any blockchain project, first of all, firsthand in the so-called sandbox, just to test all of the sites and maybe milestones of this implementation. What is an amount of the business processes that have to be changed? What kind of people do we need in this project? And do we need to teach them or not? And so on. So we can measure the financial side of the project in the sandbox before we run it in production, for example. That is why we can control this kind of risk. But stepping back, if we know the specific problem we solve with blockchain implementation, if we know the specific blockchain we need for these purposes, so then I would say that it may be highly beneficial, and we can get back our investments, I think, in a very short time, say in a year or in 2 years even. But not on a limitless period of time. So,
Thank you, I understand.
so the key question is specifics and specific problem and sandbox and specific blockchain for this purpose. Yeah, and thank you very much for your question. It was very interesting indeed. And now I think we should break for a while. We should make a break. So for 10 minutes, please. Let's get back in 10 minutes. Well, let's get back. Do you hear me well?
Yes.
Yeah, great. The next slide. Okay, now let me explain why blockchain's immutability is such a game-changing feature. So, based on my experience implementing blockchain solutions, I think this characteristic provides several crucial advantages. One of the most powerful aspects, and I want to emphasize this, is the consistency of results. What I mean, once code is locked into a blockchain, it cannot be manipulated. So let me give you a real-world example. For example, in traditional banking systems, transactions can be reversed or altered. But in blockchain, once a transaction is recorded, it's permanent and unchangeable. And what I find particularly fascinating is how blockchain technology has revolutionized transactions. Because in my work with financial institutions, for example, I've seen firsthand how it eliminates many of the inefficiencies that plague traditional systems. Now, for example, the speed, accuracy, reliability of blockchain transactions, I think they are truly remarkable. And the enhanced security aspect cannot be overstated as well, because through decentralized and immutable data storage, blockchain provides a level of security that traditional centralized systems simply cannot match. So, because, for example, I worked on projects where this feature alone was worth the investment. But perhaps most importantly, blockchain is redefining digital authentication. And I think this is not just theoretical, because I've seen how it enables unprecedented levels of trust and transparency in digital interactions. And I think the ability to verify and track transactions without relying on intermediaries is simply transforming how we think, for example, about digital trust. And these benefits are not just incremental improvements, because they represent a fundamental shift in how we handle digital transactions and also how we handle data storage. Next slide. And now let me share with you how blockchain is fundamentally changing the way we think about digital authentication. And this is something I'm particularly passionate about, because it represents a paradigm shift in digital security. And for example, in my years working with traditional authentication systems, so I've seen their limitations, but blockchain provides us with the entirely new tools for authentication and authorization in the digital world. What makes this truly revolutionary is that it works without requiring traditional centralized administrators even. Now let me explain why this is so significant. For example, in traditional systems, you typically need multiple administrators to manage access and to verify identities as well. But blockchain eliminates this need. For example, through its distributed nature, it creates a system where trust is built into the protocol itself rather than being dependent on any central authority. And what is exciting about this technology is how it enables entirely new types of digital relationships, because I work with organizations that have completely transformed their operations by leveraging these capabilities. And these aren't just incremental improvements, as I said before, because they are fundamentally new ways of establishing trust and conducting transactions in the digital space. And so you can think about the implications of this, because every digital interaction we have today relies on some form of central authority. And blockchain technology is changing their paradigm, creating more resilient and more efficient and more trustworthy systems. And I believe this is just the beginning of the major transformation how we handle digital authentication. Next slide. And now I want to share with you my perspective on how blockchain is becoming the backbone of internal transactions. And this is a development I've been following closely, and its implications are truly revolutionary. So let me start by enabling how blockchain formalizes and secures new digital relationships. For example, in my work with various organizations, I've seen how it provides a robust foundation for transactional and value-based interactions on the internet. And I think what makes this particularly powerful is that it's not just about financial transactions. I think it's about any type of digital value exchange. And one of the most fascinating aspects, and something I've experienced firsthand in implementing blockchain solutions, is I feel is how it enables multiple parties to write new entries into a system of record. And I think that this brings some precedented flexibility to the process. Because unlike traditional systems where you might have a single authority controlling all entries, for example, blockchain allows for distributed participation while maintaining security and consistency. So, and now let me give you a practical example from my experience. For example, when implementing blockchain solutions for cross-border transactions, I've seen how this flexibility dramatically reduces the complexity of international business operations, because instead of dealing with multiple intermediaries and different systems, all parties can interact directly through the blockchain. And also, this is why I believe blockchain isn't another technology trend. It's becoming, as to me, it's becoming the fundamental infrastructure for future digital interactions. And similar to how TCP/IP, for example, protocol became the backbone of internet communications, but for transactions and value exchange. Next slide. And now let me explain what makes blockchain security architecture so revolutionary. So there are two fundamental aspects that I find particularly fascinating and important for you to understand. First, let's talk about security through decentralization. For example, in my experience working with the blockchain systems, one of the most powerful features is how each record is held by multiple custodians. This is radically different from the traditional centralized systems, because what makes this so significant is that it allows digital currencies to maintain a trusted transaction network without relying on any central authority. And I've seen how this eliminates many of the vulnerabilities associated with the centralized systems. And the second aspect, which I believe is equally important, is transparency and immutability. So let me explain why this matters. Well, any third-party entity can review previous entries and bracket new ones. But, and this is crucial, all the blocks and their content are protected by powerful cryptography. And for example, during my work with various blockchain implementations, I've seen
Ну, расскажи, что дальше, ну, пожалуйста.
Тебе рассказывать.
Ну,
please turn off the mic.
пожалуйста. Ну, пожалуйста. Ну, любимая.
Все, мне надо ответить на вопрос.
I'm sorry, iPhone 123. Do you hear me? Yeah, thank you very much. So what was the break? So I think that what is particularly interesting is how these features work all together. And the cryptographic protection isn't just about keeping data secure. It's about maintaining the integrity of the entire transaction history. So I found that once students understand this dual nature of blockchain security, they begin to appreciate why this technology is so transformative, actually. Because every time I discuss this topic, I'm reminded of how the security architecture is fundamentally changing how we think about digital trust and transaction verification. By the way, I would like to ask you once again, please rename your nicknames into your surname and name, please, if you don't mind. And please do it right now. That is to identify everyone who is participating in the class. Please, would you rename your nicknames into surname and name? To my sorrow, if you do not do that, I'll be forced to ban you from the class afterwards. Yeah, thank you beforehand. Let's go on. Okay, now let me share some important insights about the challenges and limitations of blockchain technology. And as someone who has worked extensively with the blockchain implementations, I really believe it's crucial to understand both its potential and its drawbacks. For example, in my conversations with IT professionals across the industry, I've noticed a growing concern about blockchain becoming overhyped. And for example, they have a point, I believe that, because while I'm incredibly optimistic about blockchain's potential, we need to be realistic about its current limitations. So let me be specific about what I mean. And the versions of blockchain technology that are currently available, they have significant constraints. For instance, I've seen projects where blockchain was implemented simply because it was trendy, not because it was the best solution. And this is something we need to be careful about. So, and what I've learned from my experience is that blockchain isn't always the most appropriate solution for many digital interactions. And sometimes, for example, traditional databases or other technologies might be more efficient and cost effective. And I always advise my clients to, and my counterparties as well, to carefully evaluate whether blockchain is truly necessary for their specific use cases. And this doesn't mean actually blockchain isn't revolutionary, because it's absolutely is. But as with any emerging technology, we need to be thoughtful about where and how we apply it. And I've seen both successful implementations and failures, for example, and the key difference often lies in understanding these limitations and making informed decisions about when to use blockchain technology. And now, let me share with you some important considerations about blockchain's role in building the digital backbone of our future internet. And this is something I've been closely studying and actually implementing. And there are crucial aspects we need to consider. So in my work with blockchain implementations, I actually have observed how digital currencies or private cryptographic keys and the underlying blockchain technology are becoming fundamental building blocks of our digital infrastructure. But, however, and this is something I always emphasize to my students, we need to approach this development with a careful consideration. And what particularly concerns me here and what I've seen firsthand in cybersecurity incidents is that we are not the only ones advancing technologically. Because, for example, hackers and malicious actors are also becoming more sophisticated. And I think they're developing increasingly advanced technologies and techniques even to exploit vulnerabilities. And this is why I always stress the importance of a balanced approach. While we are building these new digital systems, we must remain vigilant about security. For example, in my experience, Successful blockchain implementations require not just technical expertise, but also a deep understanding of potential security threats and how to mitigate them. So, well, trust is essential, but it must be tempered with caution. So, because as we continue to build this digital backbone, we need to ensure we are not just creating efficient systems, but also secure ones. So, and also, finally, I've seen too many projects focus solely on functionality while overlooking security considerations. And now, let me address one of the biggest challenges I encounter when teaching blockchain technology. That is its inherent complexity and the often overwhelming technical jargon. This is something I deal with regularly, actually, in both academic professional settings. But in my experience teaching blockchain concepts, so I have noticed that making cryptography mainstream is particularly challenging. And for example, while the mathematical principles behind blockchain are fascinating, they can be intimidating for many people. For example, I often tell my students that understanding blockchain is like learning a new language. It takes time and patience as well. And the complexity of cryptocurrency is another sophisticated barrier. For example, when I'm consulting with business, I frequently encounter confusion about how cryptocurrencies work and their relationship with blockchain technology as well. So let me be clear. This complexity isn't just about technical understanding. It's also about grasping the philosophical and economic principles underlying these systems. And what I find particularly interesting in the concept of blockchain being that it's being anti-fragile, so-called. So this means it's actually becomes stronger when faced with challenges or attacks. And however, explaining these characteristics can be challenging due to the technical nature of how blockchain achieves this resilience. And from my teaching experience, for example, I found that breaking down these concepts into relatable examples helps overcome this jargon barrier. For instance, when I explain blockchain's anti-fragile nature, I compare it to how our immune system becomes stronger after exposure to pathogens, for example. Next slide. And now let me explain an aspect of blockchain technology that makes it particularly resilient. And one of its most remarkable features is what we call anti-fragility. As I said before, it's the ability to become stronger in response to attacks and challenges. So you can think about this the following way. For example, when traditional systems face attacks, they typically weaken or fail. But blockchain, what about blockchain? It's quite the opposite. Each attack attempt actually helps the system identify and fortify its weak points. For example, I like to compare it to how our immune system becomes stronger after fighting off an infection, for example. But however, there is a catch that I want to highlight. Because despite this incredible characteristic, many blockchain implementations aren't reaching their full potential. And what is the main reason? I would say it's efficient market exposure. So it's like having a powerful engine, but never taking it out of first gear. You may remember what I said before the break, that one of the most important problems with the blockchain implementation is to find out the proper and very specific problem we're going to solve with it. That is a key. And what I particularly want to emphasize to you is the critical importance of having a robust network of distributed nodes. This isn't just a technical requirement, so it's the foundation of blockchain's strength. And without adequate distribution across multiple nodes, we lose the very advantages that make blockchain special. And from my experience working with various organizations, so I've observed that those who succeed with blockchain implementation are the ones who invest in building and maintaining strong networks of distributed nodes. So you can think of it like a democracy. So the more participants you have, the more resilient and trustworthy the system becomes. And for example, in your future roles, you're likely to be involved in decisions about blockchain implementation. And you should remember this key point. The strength of a blockchain solution isn't just in its code. It's in the breadth and robustness of its network. Next slide. And now I want to draw your attention to a crucial aspect of blockchain that often gets overlooked in technical discussions, for example, which is the quality of data that goes into the system. So you see that blockchain's famous garbage in, garbage out principle is particularly critical here. So let me share something from my practical experience. For example, having an immutable database is only valuable if the information going into it is accurate and trustworthy in the first place. So you can think about it, if you are recording inaccurate data permanently, you are essentially preserving mistakes forever. So one of the most interesting paradoxes I've encountered in blockchain systems is what we call the 51% vulnerability. And here's the fascinating part. Despite sophisticated cryptography and consensus mechanisms, if more than half of the network's nodes collude to record false information, that falsehood can become the accepted truth in the system. And this is particularly relevant in the Bitcoin blockchain, where we've seen theoretical attacks based on this principle. And I want to understand this because it's a perfect example of how even the most secure systems can have unexpected vulnerabilities. And what I find most compelling about this challenge is that it's not just a technical problem, it's a human one, because the quality of blockchain data ultimately depends on the integrity of the people and processes feeding information to the system. Because this is why in my, for example, consultant work, I always emphasize the importance of strong data governance frameworks alongside technical implementation as well. And you should remember as well, finally, when you are working with blockchain systems in your future careers, the accuracy of input data should be one of your top priorities. The next slide. And now let me share with you why I am geniusly excited about blockchain's future, despite some of the challenges we've discussed. While it's true that, say, blockchain has its disadvantages, and I've been quite candid about those, I firmly believe that we are on the crust of something transformative. So in my work with financial institutions, I've seen firsthand how blockchain is revolutionizing cross-border payments, for example. And therefore, let me give you a concrete example. For example, a traditional international remittance cost typically hover around 20% of the transaction value. And it's quite shocking when you think about it, because the situation with the blockchain is quite another. So we are seeing this cost plummet to around 2%. So that's a game-changing difference for millions of people sending money across borders, for example. And what particularly fascinates me is the evolution of smart contracts, because when I first started working with blockchain technology, for example, smart contracts were largely theoretical. And now they're becoming sophisticated tools that can manage entire agreements from conception to execution. So, and I've seen them used in everything from simple transactions to complex multi-party contracts. And the investments pouring into blockchain technology aren't just speculative, because they're building real infrastructure for the future. And for example, from my conversation with industry leaders, I can tell you that major companies across various sectors are quietly developing blockchain application that could transform their industries even. And finally, I want to tell you to understand that while we should maintain a balanced perspective, the potential here is enormous, because whether you end up working in finance, technology, or any other sector, blockchain technology, I'm sure, will likely play a role in your professional future. And now let me elaborate on something I'm particularly passionate about. So that is how blockchain is revolutionizing international money transfers. Well, I've spent considerable time analyzing remittance systems, and the current state of affairs is, quite frankly, problematic, as you can imagine. So think about this. For example, when someone sends money international today, they're typically paying around 20% in fees. And that's an astronomical amount, especially for people sending small amounts to support their families back home, for example. Well, and I've seen firsthand how these high costs impact communities that rely on remittances. But here's where blockchain comes in, and this is what excites me. So using blockchain technology, we can slash this cost down to approximately 2%. Well, and therefore just let that think in for a moment. For example, that's a 90% reduction in costs. It's not just about the money. These transactions happen almost instantly compared to the traditional 3-5 business days. And I want to particularly emphasize the role of smart contracts in this transformation, because these aren't just simple programs. They are sophisticated tools that can handle every aspect of any agreement. And for example, from my experience working with the financial institutions implementing smart contracts, so I can tell you that they are revolutionizing how we think about automated transactions. And what I found most compelling is how this technology democratizes access to financial services. Because when we reduce costs and increase speed, this dramatically, we are not just improving efficiency, because we are opening up new possibilities for global commerce and financial inclusion. And as future financial professionals, you are likely be involved in implementing or working with these systems. So understanding their potential and limitations is crucial. And now I want to share with you what I consider to be one of the most groundbreaking aspects of blockchain technology, which is its approach to security and identity management. For example, from my years of working with the various security systems, I can tell you that blockchain security model is truly revolutionary. And let me explain why this is so significant. For example, in traditional systems, security often relies on a single point of verification. But what is in blockchain? Every transaction is verified across multiple nodes in network. So, and I like to think of it as having thousands of security guards checking your ID instead of just one. It's practically impossible to fool them all simultaneously. And what particularly excites me about blockchain's role in identity management is how it's fundamentally changing the game. So I've been involved in several identity management projects. For example, I can tell you that blockchain solutions are solving problems that seemed insurmountable, as we say, just a few years ago. So the ability to have secure, verifiable digital identities that users actually control, that's really revolutionary. And for example, when we look at cryptocurrency, this security aspect becomes even more crucial, because you see the cryptocurrency market isn't just about trading digital assets. So it's about creating a new paradigm of trust in financial transactions. And the advantages are, as to me, countless. From, say, from reducing fraud to enabling instant verification of transactions. And here, finally, I want you to understand that this isn't just theoretical, because these applications are being implemented right now in various industries. And I think as future professionals in this field, you will likely be working with these systems. And I believe that understanding the security implications will be crucial. Well, we are coming up to the next issue. And I want to come into a topic that's fundamentally transformed the financial landscape, which is blockchain cryptocurrency. And let me break this down into a way that connects all the concepts we discussed so far. So in my view, what makes cryptocurrency fascinating is as to my opinion, is its dual nature as both a digital asset and a medium of exchange. And unlike the physical money in your wallet, for example, cryptocurrency exists purely in the digital realm. But here's what makes it special. So it's secured by some of the most sophisticated cryptography we have ever developed. So, and let me share something from my experience working with various digital payment systems. What sets cryptocurrency apart is how it handles online financial transactions. And the cryptographic principles underlying these transactions are remarkably robust. And for example, I've seen traditional payment systems compromised, but the core cryptographic framework of major cryptocurrencies has remained unbreached. And what I find particularly interesting here is what I want you to understand is how cryptocurrency represents a fundamental shift in how we think about money. For example, traditional currencies rely on central authorities like governments and banks, for example, but cryptocurrency operates on a different paradigm entirely. It's designed to function without any central control, purely through mathematical and cryptographic principles. And for example, when you are working in the financial sector, which many of you will be, I think understanding this distinction isn't just academic, it's essential, because the technology behind cryptocurrency is reshaping how we think about value transfer in the digital age. And you'll need to understand both its capabilities and limitations as well. Now, let me take you back to a pivotal moment in financial history, which is the publication of Satoshi Nakamoto's Bitcoin white paper in 2008. So I remember when it first came out, and believe me, very few people understood its revolutionary potential at the time. So what fascinates me about Bitcoin's creation is how it solved a problem that had stumped computer scientists for decades, like creating a decentralized digital currency that couldn't be double spent. For example, Nakamoto's solution was brilliant in its simplicity. That is a proof of work mechanism combined with a fixed supply cap of 21 million coins. And here is a fun fact that I love sharing with my students. For example, the first real world Bitcoin transaction was for pizza. Yes, as you may know, and you heard that right. Someone paid 10,000 Bitcoins for 2 pizzas in 2010. And if we calculate it well in today's terms, so well, those were probably the most expensive pizzas ever purchased. It's a perfect illustration of how far we have come. And what I find particularly significant about the Bitcoin white paper is how it laid the groundwork for an entirely new financial paradigm. Because it wasn't just about creating digital money, it was about fundamentally rethinking how we transfer and store value in digital age. And the principles outlined in that white paper continue to influence blockchain development today, even. Because when you are analyzing new cryptocurrency projects in your future careers, you'll often find yourself referring back to this foundational concept that Bitcoin introduced before. And now let me explain what makes cryptocurrencies truly unique in the world of finance. For example, having worked with both traditional digital currencies, I can tell you that the differences are fundamental and fascinating. And one of the most intriguing aspects in my experience is that cryptocurrencies have no intrinsic value in the traditional sense. For example, unlike gold or silver-backed currencies of the past, they aren't supported by physical commodities. And this often raises eyebrows in traditional finance circles because it's actually a feature, not a bug. And what I find particularly revolutionary in this case is the concept of decentralization. So you can see when I worked, for example, in traditional banking, every transaction had to go through multiple layers of centralized control. But what with cryptocurrencies? The supply and governance are completely decentralized. For example, no single entity, not a government, not a central bank, no one can control it. And here, what I wanted to really understand, which is cryptocurrency exists purely in digital form. This isn't just about replacing paper money with the digital numbers, for example. It's about creating an entirely new form of value transfer that's native to the digital world. And therefore, the most profound aspect in my view is the attempt to create money that's free from government manipulation. And whether this is good or bad is still debated, but the technological achievement is remarkable. So, and for sure, I believe that you will need to understand these characteristics deeply, as they fundamentally change how we think about money and value. And now let me share with you what I consider one of the most revolutionary aspects of blockchain currency, that is its ability to eliminate intermediaries from financial transactions. And this key characteristic that fascinates me about blockchain currency is its immutability. Once a transaction is recorded, it can be duplicated or altered. And this is fundamentally different from traditional digital payments, where, believe me, duplicate transactions and fraud are constant concerns. And for example, I've seen how this feature alone has transformed how businesses think about digital transactions. And also, I would like to tell you that there is a peer-to-peer nature of these transactions. So you can think about it when you, for example, send money. Traditionally, it goes through multiple intermediaries, your bank, a clearinghouse, a recipient's bank, and possibly others. But with blockchain currency, it's direct, like handing cash to someone, but digitally and securely. And here's what I want you to grasp, which is the absence of a middleman. It isn't just about convenience or cost savings. It represents a fundamental shift in how we think about trust in financial transactions. And in traditional systems, for example, we trust intermediaries to validate transactions, But in blockchain, we trust mathematics and cryptography. And this direct transaction capability has implications far beyond simple payments. For example, in your future careers, you'll likely see this principle applied to various financial instruments and services, fundamentally changing how we think about financial intermediation. And now, the next slide. Now, let me explain something fascinating about how cryptocurrency value and stability work. So it's quite different from traditional currencies, and I think understanding this is crucial for the future in finance. So I've observed that the dynamics of cryptocurrency value are uniquely dependent on two key factors, which are user activities and protocol governance. And unlike traditional currencies where central banks control supply and value, cryptocurrencies operate on what I call a programmatic consensus. So let me emphasize something particularly important about miners, therefore. They are not just processing transactions, so they are fundamentally to the entire ecosystem stability. And I can tell you that their role is far more complex than most people realize, because they are performing sophisticated computing functions that not only record transactions, but also secure the network and maintain its integrity. And what I found most intriguing is the incentive structure, because miners receive newly created cryptocurrency units and transaction fees as rewards. And this isn't just compensation, it's a carefully designed economic model that ensure the system's sustainability. For example, in my analysis of various cryptocurrencies, I really seen how different reward structures can significantly impact network stability. And for example, for those of you who will be working in cryptocurrency markets, I think understanding these protocols isn't just academic, so it's essential for predicting market behavior and assessing cryptocurrency project. And now let me walk you through this fascinating diagram that illustrates the entire life cycle of a cryptocurrency transaction. And this is one of my favorable diagrams because it perfectly captures the elegant simplicity of how cryptocurrencies work. So starting at the top left, you can see that everything begins with the transaction request. So in my experience, for example, implementing blockchain systems, this is where the magic starts. So the request gets broadcast to what we call a P2P network. So you can think of it as a vast web of computers all working together to validate transactions. And what I find particularly elegant is the validation process in the middle of the diagram. So you can see those nodes, for example. Each one is independently verifying the transaction using sophisticated algorithms. And for example, and I can tell you that this is radically different from how conventional transactions are verified. And you can notice also the bottom part of the diagram where it shows three key characteristics of cryptography, a cryptocurrency. No intrinsic value, no physical form, and no central control. And this is crucial to understand because we're dealing with a completely new paradigm of value exchange. And the most impressive part, in my view, is how the verified transaction gets added to the blockchain because it's permanent and unalterable. And I have worked with many database systems, but none match the immutability of blockchain. And that orange, for example, you can see at the orange box on the chain. So once it's there forever. And also, I wanted to pay special attention to how this entire process happens without any central authority. So, because I think that is crucial for you to understand. And now, let me explain one of the most fascinating aspects of blockchain technology that sets it apart from traditional systems. So, I mean, the remarkable thing about blockchain is its complete transparency in transaction tracking. For example, imagine being able to see every single transaction that has ever occurred with a particular cryptocurrency unit since it was created. That's exactly what blockchain enables. And when I talk about transparency, I mean that anyone, anywhere in the world with an internet connection can examine these transactions. And also, this isn't just about visibility at all. It's about creating a truly global ledger system, because you can think about this, the entire transaction history is replicated and stored on computers worldwide. And what makes this particularly powerful is that this global distribution isn't just a show. So each copy of the ledger serves as a verification point, making the system incredibly resilient. And for example, if one computer goes down or it's compromised, say, thousands of others maintain the accurate record. So I'm going to give you a practical example here. For example, when you make a Bitcoin transaction, it doesn't just get recorded in one central database. Instead, it gets copied to thousands of computers across the globe. And this means that to alter any transaction record, someone would need to simultaneously hack not just one, but the majority of these computers, making it virtually impossible to manipulate the system. And this global replication combined with the transparent access creates what we call a trustless system. Not because there is no trust, but because the system is designed in such a way that trust is built into its very architecture. Next slide. And now let's dive into what makes blockchain truly secure against hacking attempts. So I want to share with you two critical features that make blockchain such a safe, formidable security system. First, let me explain the ingenious way transactions are protected. Every block in the chain is connected using advanced cryptography. And you can think of it as a digital log that's virtually impossible to pick. And what's fascinating about the structure is that if anyone tries to alter even a single transaction, they would need to change every subsequent block in the chain. And I think this is practically impossible given the computational power required. So let me give you an example using Bitcoin system. Every 10 minutes, all completed Bitcoin transactions are gathered together and sealed into what we call a block. It's like taking a snapshot of all the financial activity that happened in that time window. For example, once the block is sealed and added to the chain, it becomes permanent. And what is particularly elegant about this system is how it creates what we call immutability. So in other words, the inability to change historical records. So you can see each block contains a cryptographic reference to the previous block, creating an unbreakable chain. So if a hacker wanted to change a transaction from the last week, they would need to recalculate every single block that's been added since then, and do it faster than new blocks are being created. So, and therefore the computational power required makes these practically impossible. And this is why I often tell my students what that blockchain isn't just secure, it's revolutionizing our entire concept of digital security. And now let me introduce you to the Bitcoin, which is perhaps the most revolutionary application of blockchain technology to date. So I want to emphasize three fundamental characteristics that make Bitcoin unique in the world of finance. First and foremost, Bitcoin represents something entirely new in our financial history. It's a purely digital, completely decentralized form of currency. What is fascinating here is its use of cryptography for security, which is why we classify it as a cryptocurrency. For example, when I say cryptography, I'm talking about mathematical principles so secure that even the world's most powerful computers couldn't break them. So I'd like to highlight here an important milestone, which is Bitcoin has achieved something remarkable by becoming the largest cryptocurrency in the world by market capitalization. So this isn't just about the size, it's about market confidence and widespread adoption. And for example, when we look at the numbers, Bitcoin's market dominance becomes even more impressive. And the third point I want to emphasize is how Bitcoin operates on what we call a decentralized ledger system, that is blockchain. This system is used for everything Bitcoin related, creating new Bitcoins, trading them, storing them, managing their distribution. And what is remarkable here is that the entire system operates without any central authority. So, as we said it before. And now let me walk you through how Bitcoin actually works in practice, using this diagram to illustrate the system elegance and simplicity. So at the heart of the system, we have a Bitcoin miner, or Bitcoin miners. So these are the computers running the Bitcoin code and maintaining the blockchain. And what's fascinating is how these miners act as the system's validators, processing every single transaction that occurs. And now let's for a typical Bitcoin transaction. For example, imagine I'm a sender on the left side of our diagram wanted to transfer Bitcoin to a receiver on the right. And therefore, the transaction gets broadcast to the network of computers running the Bitcoin code. And these miners then compete to validate the transaction by solving complex mathematical puzzles and a process which we call proof of work. And the beauty of the system is that it eliminates the need for traditional intermediaries, as we said it before. And now I want to delve you into a crucial aspect of Bitcoin's ecosystem, which is the miners and the fascinating concept of Bitcoin's limited supply. And this is one of the most ingenious elements of Bitcoin's design that I find particularly compelling, actually, because so let us start with the miners. These aren't people with pickaxes. They are individuals or companies operating powerful computers that process transactions on the blockchain. And for example, in my view, they're essentially the backbone of the entire Bitcoin network. And for example, without miners, the system simply couldn't function. So they're responsible for validating every single transaction and maintaining the integrity of the blockchain. And the most interesting thing here is how Bitcoin's creation is tied to this mining process. For example, you can see new Bitcoins aren't just created out of thin air, so they are realized as rewards for mining. But here is the brilliant part. So as we say, Bitcoin has a hard cap of 21 million coins. And this isn't just an arbitrary number. So it's fundamentally built into Bitcoin's code, and it can be changed. And this fixed supply is what makes Bitcoin radically different from traditional fiat currencies, because For example, when I teach this concept, I often contrast it with the how central banks can print more money at will. So because with Bitcoin, there is no such option. And this scarcity is internationally designed to create price stability in the long term, though we certainly see significant volatility in the shorter term. And I think that this combination of mining rewards and limited supply creates what I consider to be one of the most sophisticated economic systems ever designed. And now let me explain the fascinating process of Bitcoin mining, which I think consists of 4 essential steps that work together to maintain the integrity of the entire system. So looking at this diagram, you can see how each step builds upon the previous one. So the first critical step is transaction validation. And for example, as a miner, when I receive a new transaction, I need to verify that transaction and verify that it meets all the necessary criteria. And this includes checking, for example, if the sender has sufficient funds and if the digital signatures are valid. And it's like being a digital bank teller, for example, but the verification process is completely automated and foolproof. And the second step involves something we call the proof of work algorithm. And this is where things get really interesting, because miners compete to solve complex mathematical puzzles that require significant computational power. For example, I often tell my students to think of it as a global mathematical competition where the winner gets to add the next block to the chain. And the third component is what we call independent aggregation. For example, once a miner successfully solves the puzzle, they get to aggregate or bundle multiple validated transactions into a single block. And this is really crucial for the system's efficiency. And finally, we have the confirmation step. And this is where the network reaches consensus on the validity of the new block. Only after this confirmation does the block become a permanent part of the blockchain. And the beauty of this system is that it's completely autonomous. No human intervention is required. And once, for example, once the rules are set in place. Next slide. And now let me introduce you to one of the most important practical aspects of using Bitcoin, the Bitcoin wallet. So I like to explain this concept by drawing a parallel with traditional banking, but with some crucial differences that make it uniquely powerful. So you can think of a Bitcoin wallet as your personal banking interface in the cryptocurrency world. However, unlike a traditional bank account, your Bitcoin wallet does something quite remarkable. So it generates unique Bitcoin addresses for you. And this is one of these features I found most fascinating about the technology. And therefore, let me explain how it works in practice. When you first install a Bitcoin wallet on your computer or mobile device, it automatically creates a first Bitcoin address. And but here's what's special. So you can create multiple addresses, and each one acts like a separate account with its own balance. It's like having a multiple bank accounts, and but there without the additional paperwork or fees. And what I want to emphasize is that your wallet doesn't actually store the Bitcoins themselves. Rather, it stores the cryptographic keys that give you access to Bitcoins on the blockchain. So you can think of it like having the keys to multiple safety deposit boxes or in global digital bank, for example. And the beauty of the system is its combination of security and flexibility. So you can easily receive Bitcoins from others and store them securely and send them anywhere in the world, all from one interface. And for example, unlike the traditional banking hours, the system operates 24/7. Well, let's go on with the next slide. How risky is Bitcoin? First of all, let me address one of the most common questions I got from the students about Bitcoin. How secure is it really? And the answer lies in the remarkable cryptographic technology that underpins the entire system. And what I find absolutely fascinating about Bitcoin security is that it uses a so-called SHA 256 algorithm, which was actually developed by the US National Security Agency. And now you might wonder why this is significant. Well, let me share something mind-blowing with you. And this algorithm creates a level of security that's almost impossible to comprehend. And let me put this in perspective for you. To crack this encryption, you'd need to test around 2 powers 256 different combinations. And that's such an astronomically large number that it exceeds the number of atoms in the observable universe. And for example, when I tell this to students, they often struggle to grasp just how secure this makes Bitcoin. But here's what makes this even more interesting is this incredible level of security. It isn't just theoretical. It's being tested every single day by the entire global network of Bitcoin users. And so far, the core cryptographic protocol has never been breached. Never. And this is why I can confidently say that when we are talking about the cryptographic security of Bitcoin itself, the risks are virtually non-existent. And of course, there are other types of risks associated with Bitcoin, but the underlying cryptographic technology is practically unbreakable with our current computing capabilities, at least. Well, now let me walk you through the economic model that makes Bitcoin truly unique. And what I find here particularly brilliant about the Bitcoin design is how it carefully controls the creation of new coins through a process that's both predictable and mathematically precise. And now let me explain how this works in practice. New Bitcoins only come into existence through the mining process, which in turn happens every time a new block is created. But here's the clever part, which is the rate at which these new Bitcoins are created follows a strict predetermined schedule that's built into the code. And what is very interesting, as to my opinion, is the halving, so-called halving mechanism. What does it mean? It means that every 210,000 blocks, which works out to roughly every 4 years, something remarkable happens. That is, the number of new Bitcoins created per block is cut in half. And this is what we call the halving event. And let me give you a specific example. During the first 4 years of Bitcoin's existence, miners received for about 50 new Bitcoins for each block they created. And after the first halving, this dropped to 25, then to 12.5, and so on. And the systemic reduction in the rate of new Bitcoin creation is what economists call a disinflationary model. It's completely different from traditional currencies where central banks can create new money at will, just will. And in Bitcoin's case, the rules are set in stone from the beginning, creating what I believe to be one of the most sophisticated monetary policies ever designed. And now let me share with you one of the most fascinating aspects of Bitcoin's long-term economic design. We are looking at a remarkable milestone in the history of currency, which is a mathematically certain future that extends over a century ahead. And as of now, approximately 13.44 million blocks have been mined in the Bitcoin network. But what I find truly remarkable is the precise cap that's built into the system. For example, by the year 2140, yes, you heard it right, 2140, we will reach exactly 21 million Bitcoins in circulation. Not 21 and 1, not 20.9 million, exactly 21 million. And this precision is what makes Bitcoin's monetary policy so unique. But here's where it gets really interesting. You might wonder what happens after all Bitcoins are mined. Well, this is where Bitcoin's economic model shows its brilliance, because after 2140, miners won't receive new Bitcoins as rewards, but they will still be incentivized to maintain the networks through transaction fees. It's like transitioning from a gold mining economy to a service economy, but it's all planned out in advance. For example, when I explain this, I usually emphasize how this creates a perfectly predictable supply curve. Something that's never been possible with any other form of money in human history. And this predictability combined with absolute scarcity, as to my opinion, makes Bitcoin fascinating experiment in monetary economics. And now let me share with you some remarkable statistics that demonstrate just how significant cryptocurrency has become in our global financial system. And what we are witnessing is really nothing short of a financial revolution. So, and for example, when I tell that to students, I mean about cryptocurrencies market capitalization, that it is reaching 3 trillion in 2021, it has reached. And many of the students are astonished, of course. So you can think about that number for a moment. It's larger than the GDP of many developed nations, for example. And this isn't just impressive growth, though. It's a clear indication that cryptocurrency has moved far beyond its origins as a niche technology experiment. And what is very interesting as to me is how this massive valuation reflects cryptocurrency's potential to achieve something unprecedented, which is the status of a global reserve currency. And this isn't just speculation anymore. So we are seeing exactly major financial institutions or corporations and even countries beginning to treat cryptocurrencies as a legitimate financial asset. So let me put this in perspective. Just a decade ago, many, for example, dismissed cryptocurrency as a passing fad. But now it's become impossible for the traditional financial world to ignore it. For example, major banks are creating crypto trading desks, or institutional investors are adding it to their portfolios, and even central banks are exploring their own digital currencies in response. And this transformation in turn represents one of the most significant shifts in global finance. I think since the advent of electronic banking. And now let me outline 4 critical aspects that I believe will shape the future of cryptocurrency. And as someone who's been studying and teaching about this technology, I find these dynamics particularly fascinating. First, let's talk about innovation. What excites me most is the constant development we're seeing in this space. And it's not just about new cryptocurrencies anymore. We are witnessing the emergence of entirely new applications built on blockchain technology. And the pace of innovation is simply breathtaking. And secondly, when it comes to adoption, we're seeing something remarkable. More and more businesses, from small shops to major corporations, are beginning to accept cryptocurrencies as payment. And what I find particularly interesting here is how this adoption is happening across different sectors and geographical regions. The third aspect I want to highlight is resilience. That is, despite numerous challenges like market crashes, regulatory crackdowns, technological hurdles, for example, the crypto economy has shown remarkable staying power, because I've seen it bounce back from setbacks that many thought would be fatal. But however, I must also address the challenges ahead. For example, the industry faces increasing regulatory scrutiny, and rightfully so. We are seeing also governments worldwide grappling with how to regulate this new asset class. And there are also technical challenges around scalability and environmental impact that need to be addressed also. And as to me, this combination of opportunities and challenges makes cryptocurrency one of the most dynamic fields in finance today. Well, and today I would like to take you beyond the familiar territory of cryptocurrencies and explore 2 fascinating blockchain applications that are reshaping how we think about digital ownership and organization, which are NFTs and DAOs. Well, let me start by explaining why these innovations matter for the finance world. And while Bitcoin and other cryptocurrencies demonstrated blockchain's potential for financial transactions, NFT and DAO show us how this technology can revolutionize digital ownership and also organizational governance. And as we go deeper into the topic, I want you to think about how these technologies might impact your future professional endeavors, for example. And whether you are interested in digital art or gaming or investment or organizational management, whatever, but understanding NFTs and DAOs will give you valuable insights into the evolving digital landscape. And I've been following these developments closely, and I can tell you that we are witnessing a fundamental shift in how digital assets are valued and how organizations can be structured. And the principles we've discussed today are already being implemented by major companies and innovative startups alike. And what is exciting here, most of all about these technologies, is their potential to democratize both ownership and governance. For example, through NFTs, digital creators can finally have verifiable ownership of their work, for example, while, for example, DAOs are showing us new ways to organize and make decisions collect. Next, let me break down how NFTs can actually work in practice. So you can think of an NFT as a unique digital certificate, like deed to a house, for example, but for digital asset. And what makes it special is that each one has its own cryptographic signature that can be replicated. So, and the beauty of using blockchain for NFTs lies in its, I would say, transparency and immutability. And for example, when I create or transfer an NFT, that transaction is permanently recorded on the blockchain. It's like having a public notary verify your ownership, but it happens automatically and can't be tampered with. And here, what is fascinating, NFT solve the digital scarcity problem. For example, in the past, digital files could be copied endlessly, making it impossible to establish true ownership. But with blockchain technology, we can now create verifiable scarcity for digital assets, giving them real value. And let me give you a practical example. For example, when an artist creates a digital artwork and mines it as an NFT, they're essentially creating blockchain-based certificate of authenticity. And even if someone copies the image file, they can't replicate the unique proofs ownership for it, because that's recorded on the blockchain. And this infrastructure enables something remarkable. We can now buy, sell, and trade digital items with the same confidence we have in physical goods. And the blockchain provides an unbroken chain of custody from the original creator to the current owner. And let us talk about a few fascinating market insights about NFTs as of the current. So I've been closely monitoring these trends, and the data tells an interesting story about where this technology is hidden. And one of the most significant developments I want to highlight is, for example, Coinbase NFT platform, because with an anticipated user base of 2 million people, it really represents a major shift in how NFTs are being integrated into mainstream cryptocurrency platforms. And this isn't just about numbers, it's about accessibility and mainstream adoption. And for example, when we look at demographics, we see some interesting patterns. There is a notable gender disparity in NFT collecting, with, for example, men showing high engagement rates. And as someone who studies market dynamics, I find this particularly interesting because it points to potential untapped market and opportunities for growth. And now let us talk about the challenges. The market really has experienced a significant quarterly trading loss of approximately $450 million. And in my analysis, for example, this isn't necessarily a negative sign, because it's more indicative of a market normalizing after the initial hype cycle. And what I find particularly compelling is how public interest has evolved since early 2022, and we're seeing a shift from speculative buying to more sustainable, utility-focused applications now. And I think that this maturation process, while challenging for some investors, is actually strengthening for the foundation of the value of NFT technology. And now I want to introduce you to one of the most revolutionary applications of blockchain technology, which is decentralized autonomous organizations, or DAOs. And overall, in my view, this is where blockchain truly shows its potential to transform organizational structures. Well, let me explain how DAOs work. So in their core, they operate on blockchain technology, but what makes them unique is their ability to function without traditional hierarchical management. Because instead of every decision is made through smart contracts and community voting. And as someone who studied organizational structures, I find this particularly fascinating. And what is exciting about DAOs is their automated operations through smart contracts. For example, you can imagine an organization where routine decisions are executed automatically based on predefined rules, while, for example, strategic decisions are made through community consensus. And this isn't science fiction, it's happening right now. However, I want to be transparent about the challenges. For example, DAOs face significant hurdles in terms of scalability and legal recognition. And for example, in my experience studying emerging technologies, these are typically growing pains for revolutionary innovation. And therefore, the key applications we're seeing are in finance and governance, but the potential extents are far beyond these areas. So you can think, finally, you can think about this. We are witnessing the emergence of organizations that can operate 24/7 and make decisions transparently and give every stakeholder a direct voice in governance. And this is why I believe DAOs represent a fundamental shift in how we think about organizational structure and management. Well, now let me share some remarkable statistics that demonstrate just how significant DAOs have come. So as of April of the current year, we are looking at market capitalization of $22 billion. And to put this in perspective, that's larger than many traditional corporations. And what is particularly striking is the growth rate. For example, we've seen a staggering 60,000% increase in active DAOs since 2019. And for example, in my years of studying financial markets, we've rarely seen actually such explosive growth in any sector. But this isn't just about numbers. It represents really a fundamental shift in how people think about organizational structures. Well, now let's look at community engagement. For example, with 6.8 million governance tokens holders and 2 million active voters, we're seeing, I think, unprecedented levels of direct participation in organizational decision making, and that is really exciting. That's about these numbers. They represent real people taking active roles in governance. And for example, the treasury assets of $28 billion in venture capital investments of 160 million in the first quarter of 22 tell us something crucial, that is institutional investors are taking DAOs seriously. And for example, from my perspective as a financial technology expert, this institutional buy-in is a strong indicator of the technology. And these metrics aren't just impressive numbers, I think, but they represent a growing confidence in decentralized governance models. And for example, when I look at these trends, I see a future where DAOs could become as common as traditional corporations are. And before we wrap up today's lecture, this part of the lecture, I want to emphasize the key points that I believe are crucial for understanding blockchain technology's transformative potential. Therefore, let me summarize what we've covered. first, we discussed how blockchain emerged as a response to the vulnerabilities, and we saw in those we saw in centralized financial systems. And what makes these particularly significant is its ability to create decentralized and transparent ledgers that don't require trust in central authority. And when we then explored how Bitcoin pioneered the practical application of blockchain through proof of work mining, and this was followed by Ethereum's revolutionary introduction of smart contracts, which I believe was a game-changing moment that opened up entirely new possibilities. And what I find most exciting is how blockchain is now being deployed across multiple sectors. For example, from my experience working with various industries, I've seen really firsthand how it's transforming everything from supply chains to even healthcare. And the applications in identity management, for example, and payments are practically promising. And finally, I want to acknowledge that challenges we discussed before, particularly around scalability and energy consumption. So, however, as someone who's been studying this technology since its early years, I can tell you that these challenges are driving rapid innovation in the field. And the capabilities are evolving at, I think, at an unprecedented pace. Well, let us take a couple of minutes to read and answer the quiz. And then when we will review the correct answer, please read the question and select one of the options, only one of the options. The question is, which of the following features of blockchain technology make it uniquely suited to securing decentralized digital transactions? So please take your time. Please write your choices into the chat. Yeah, great. You have chosen the third answer, the third option. So let's look it up. Yeah, that's right. That's quite right. Yeah, you are great. And by the way, so to my sorrow, we have not time left for discussion of these issues, but nevertheless, so I will provide you with the presentation afterwards, and you will be able to think about these issues just to go deeper into the topic. And here you can find the glossary of the topic as well, and 365 days a year.